All right. So, I know this is a Nearpod, but you should absolutely, for this, have a pencil, a calculator, and a piece of paper. You should definitely have that. And you're going to need that moving forward for the next few assignments anyway, because you're going to want to be taking some type of notes on this, just generally, but you should also be ready to do some practice problems. So, we're going to start by talking about motion. Now, we've talked about Newton's first law already: an object in motion remains in motion unless acted upon by an outside force. And then, as well as an object at rest will remain at rest unless acted upon by an outside force. That's a quick summary of it. It's not perfect. But what if I were to tell you that those two separate sentences are actually the same sentence unless an object is spinning? So, how can I prove that to you? So, first I want you to define the term relative. Okay, so if you define the term relative, you probably, first thing in your head is probably like, oh, like a cousin or an uncle or a sibling, right? We usually use the term relative to describe someone who we're related to. But in this case, relative motion, or motion being relative, is the idea that the only way to tell if something is moving is if it's moving compared to something else. So here's the little game that I like to play. Imagine you and a tennis ball are in outer space, and there's no stars around you. It's just completely dark. Like the sky everywhere is completely dark, and you're just floating there in space with the ball. So the ball is there in front of you, and you're there, and you say, oh, I'm not moving because I see the ball and me and the ball are not moving. But what if you and the ball were moving, I don't know, that way at the same speed and in the same direction, just that way? If you were moving at the same speed in the same direction and everything around you is black, you would have no idea that you were moving. Because if you can think about yourself being in an airplane, right? And you're cruising in an airplane, it's not going up, it's not going down, it's just going the same speed in the same direction, and you flip a coin, although you're going 400, 500 miles per hour, that coin goes straight up and comes straight back down and lands in your hand. It doesn't go straight up and zoom back behind you because you and the plane and the penny are moving together. And the only way that you can tell that you're actually moving is maybe looking out the window, seeing clouds flying by, or seeing the ground slowly moving by you because you're so high up. So the point is, when we say motion is relative, we just mean we can't tell if something's actually moving unless we have another thing to compare it to, right? We're all on the earth. We're all traveling around the sun going about 50,000 miles per hour. We don't feel it, and that's because we're going at a consistent speed. The speed isn't changing much. So because the speed isn't changing much, we're not feeling that change. All right? So that's the little intro to motion being relative. There's a video that goes along with it. This video is crazy. I'll show it to you at the end. Okay, so here's where we're going to get into math. Now, it's going to, test your algebra skills as we move through this. We're going to start nice and simple, and it's going to get more and more complicated, okay? So we're going to get into some math. You should have paper for this, and a pencil, and a calculator, okay? And also be open. So this is going to lead us into understanding Newton's second law. So, nice basic velocity problem. So, assume all these examples are an object that moves in one direction. So these are objects moving in a perfectly straight line, all right? And their speeds are remaining constant. So they're not speeding up, they're not slowing down, they're remaining constant. Or at least we're determining their average speeds. So a bicyclist covers 20 kilometers in 1 hour. What is the bicyclist's average velocity? Just want to make sure I was actually recording. Okay, so let's get into this. If we were to determine the velocity of an object that's covering 20 kilometers in 1 hour, we're going to use the velocity formula. So we're just, normally I'll have a bigger area to do this, but the velocity formula is distance divided by time. very similar to speed, and we'll talk about speed after this. But distance divided by time is why we say miles per hour. Miles is a distance, and then the per is just the slash between the distance and the time, right? And hours is time. So miles, distance, per is the slash, hours is the time. Miles per hour. So that's our velocity, or that's our speed. In this case, our distance from the question, d equals 20 kilometers. 20 kilometers. And our t, or our time, is 1 hour, right? And we don't know what velocity is. So we can set this up now because we have a distance and we have a time. We have one half of the equation complete, or one side of the equal sign complete, so we can figure out the other side. 20 kilometers divided by 1 hour equals 20 kilometers per hour. How's that? 20 kilometers per hour. Very cool. Hopefully that makes sense. So let's keep moving. So when discussing speed, we like to talk about the average velocity. We're not going to talk about this. Now let's talk about speed versus velocity. So I've been using the term velocity and speed kind of interchangeably so far, but they are not really interchangeable. So here's the general idea. Speed and velocity are both measured in distance per time. But a speed is going to be just any old distance per time, while a velocity is a specific time with a specific direction, right? So when we're talking about a velocity, we're saying, okay, if you're in a car going around a turn, at one point in that turn, like if you choose any point in that turn, that car is going a specific direction and it's going a specific speed. So speed is going to be not just based on a direction, while velocity is going to be a speed with a direction. So velocity comes with what we call a vector, meaning that it's giving us a direction, and the length of this arrow tells us the speed. A short arrow, like this one, is going to be a slow speed, while a long arrow is going to be a long speed. Now, the length that we make those arrows doesn't matter, as long as a longer arrow is going to be a faster speed, a shorter arrow is going to be a slower speed, and if this is twice the size of this, or twice the length, it should be twice the velocity. I know this is all technical stuff. You don't worry about this. Don't worry about this. It's just technical stuff. Let's get into velocity. Velocity is change in an object's position. So if I go from here to here, I just changed my position. And if we measure where I started from to where I ended, that is our distance. So this just means distance. Velocity is change in an object's position or a distance over time. And the slash, we can say the word per for. So distance per time. So let's try out, yeah, there's the nice formula. There it is, v equals d over t. Let's try out a practice problem. So this is what I expect you to do every time you get to a physics question. And you're going to say, oh, why? Because for some of you, this might be so simple. It gets hard. It gets difficult. There's multiple equations. There's multiple ways of phrasing questions. Do these steps every single time and you'll be okay. Anne walked 1.5 miles south to her house in 0.5 hours, or 30 minutes. What is Anne's velocity? So, what we need to do here is understand that we're being asked for a velocity, right? We're given miles and we're given hours. So in this case, if we're given a velocity, or if we're trying to find a velocity and we're given miles and we're given hours, we need v equals d over t, or velocity equals distance divided by time. So in this case, what do they give us? So this is where I start. What do they give me? In this case, they say 1.5 miles. Miles is a unit of distance. So d equals 1.5 miles. What else did they give us? So 1.5 miles south to her house in 0.5 hours. Hours is a unit of time. So 0.5 hours is a unit of time. And now finally, possibly the most important step is going to be, what is Anne's velocity? They're asking about velocity, so we don't know the velocity. Now I look, okay, I've got a V, I've got a T, I've got a D, right? I've got all these things. What's the formula that I'm going to use? V equals D over T. Nice. And do we have the distance? Do we have the time? Do we have, like, so if you see the equal sign, do we have the entire side of an equal sign? So in this case, we do have a distance, we do have a time, and that means we can solve for velocity. So distance equals 1.5 miles divided by 0.5 hours. So if we do this in a calculator, plug it right in, 1.5. Remember that this per is going to be our division. So this is going to give us 3.0 miles per hour. So what does that mean? If Anne walks 1.5 miles in half an hour, that means that if we go for another half an hour or 1 full hour, she'll have walked 3 miles. So if she's walking 3 miles per hour, that means if she does half of that amount of time of walking, she'll go half that distance. And 1.5 miles is half the distance of 3 miles. So that's the way that I like to think of velocity. This is 3 miles for every hour that goes by. So in this case, if we do half an hour, we're going to do half the distance. Okay? So hopefully that makes some sense. So this is the basic steps. I write the formula. Step 2. V equals what? D equals what we're given. T is given as 0.5 hours. And then we just plug it into a calculator. V equals 1.5 miles divided by 0.5 hours. V equals 3 miles per hour. There's our units. We just carry our units through. Miles over hour, and I got miles slash hour, or miles over hour. Okay, so here's a second velocity practice problem. I'll let you try this on your own if you can. All right. So Jack drove 100 kilometers. So they give us 100 kilometers. This is going to be a distance, right? A kilometer is a distance from his wife's job to his friend's house. The trip lasted 93 minutes. So I always write down what they give me. 93 minutes. What is Jack's average velocity? So minutes is going to be a time, and they're asking us to find the velocity. I don't know what the velocity is. So again, the formula that we're going to need that has a V, a T, and a D in it, V equals D over T. Right? That's the velocity formula. Do we have the one side of the equation completely filled? Yeah, we have a distance and we have a time. Let's plug that in. 100 kilometers divided by 93 minutes. So I can't do that in my head, but it's something like 1.07. That's probably it. And the units are, we're just going to carry through kilometers over minutes. Kilometers slash minutes. There we go. All right. So let's try a difficult question. Try a more difficult question. All right. So practice problem 3. This is where it gets difficult. Ready? Ready? A bird migrates south at an average velocity of 10 miles per day. Velocity. So they give us a velocity is 10 miles per day. Okay? So V equals 10 miles per day. So this is our first time getting a velocity given to us. How many days passed after the bird traveled 155 miles? They give us 155 miles. Miles is a unit of distance. What are they asking us? How many days? Days is a unit of time. We don't know what time is. So here's the deal. V in our velocity equals distance over time. V is on one side of the equation, while D, or distance, is on the other side of the equation. And we're asked to find T. We can't plug something into an equation with one thing on one side of the equation, the other thing on the other side of the equation. We need to balance this equation out. all right? So we need to set t to be alone. So here's the basic rules, all right? If we have distance divided by time, we need to move time to the other side. You remember this from algebra, right? If we move time to the other side, we're going to, since we're divided by time, we need to multiply by time on both sides. So since over here we have a time multiplied and divided, that cancels. We cancel time. Time is canceled on that side. And now we have t times v equals d. So t times v equals d, meaning that time times velocity equals distance. What am I solving for? I'm solving for time, so that means I need to move velocity to the other side. If I multiply by velocity, in order to get it to the other side, I need to divide by velocity on both sides. So now velocity cancels out, and I have t equals d over v. Do I have a v? Do I have a d given to me? Yes, I do. So now I have one side of the equation all set up. So I can plug this in. I'm going to use this space up here. T equals d over v. Distance is going to be 155 miles, while the velocity is going to be 10 miles per day. So what's the question asking me? How many days passed after the bird traveled 155 miles? So let's just take a step back before we even figure this out. If a bird every single day travels 10 miles, 10 miles, 10 miles, 10 miles, that means after one day, it'll go 10 miles. After 2 days, 20 miles. 3 days, 30 miles, right? So if we want to get up to 155 miles, we have to just think if every day is going to be an additional 10, that means this bird has to be traveling for 15.5 days. All right? So if we plug that into the calculator, 155 divided by 10, that equals 15.5 days. So how does this make sense? If a bird travels 10 miles every day for 15.5 days, so 10 miles for 15.5 days, or 15 and a half days, it will have traveled 155 miles by the end of that journey. So all these numbers end up checking each other out and end up balancing out, right? So let me just show you how to do this algebra again. So how do we solve using the velocity formula? Remember, if we divide by time, to get it to the other side, we need to multiply by time on both sides, right? So like on both sides of the equal sign, we need to multiply. That cancels out the t on this side because we have a divided by t and we have a multiply by t. That cancels out. So we end up with this simple formula. T equals v, time multiplied by velocity equals distance. We're trying to get time to be alone in this case, right? So if we need to get time to be alone, we have multiplied by velocity on one side, so we need to divide by velocity on both sides, which will cancel the multiply by velocity because we're divided by velocity on this side, right? And then we'll just end up with t equals distance over velocity. T equals distance over velocity. And then we can plug in our numbers. We have a distance, we have a velocity, right? 155 miles divided by 10 miles per hour. And then we can just plug it in. Here's another way though. If you want to do it this way, that's fine. We need to find time for this question. So if we need to find time for this question, and we do v with the d on the top and the t there, how do we find time? I cover up time, right? So let me cover up time. What are we left with? D on top of v, which is what our formula gave us. So this may be a lot of information in one little section, but it should be a good review for algebra. You've definitely done something like this before. So hopefully it'll make a little more sense as we go through more practice problems.